right, so we're going to use this equation again to determine if we are dealing with a parabola. So we want to prove that if the graph is a parabola, then BC is equal to 0 or A is equal to B squared over 4C. Now, what we're going to do here for this proof, as you can see, this statement is of the form P implies Q or R. Okay? So we're actually going to use the logical equivalence that P and not Q implies R. Okay? So instead of trying to prove it in this form, we're going to prove it in this form because that's going to be a little easier on us. Okay? So let's go ahead and go down a little bit. So let's start our proof. So we're going to assume, we're going to assume that the graph is a parabola. The graph is a parabola, and that, so the negation of this would be BC is not equal to 0. Okay, so let's go ahead and do this. So the graph is a parabola implies that, so a parabola, that implies that B squared minus 4AC is equal to 0. All right, so of course we can add 4AC to both sides. So if we add 4AC to both sides, this means that B squared is equal to 4A, well, 4AC, right? Let me fix this a little bit. Okay, so now we are really close to what we want. We actually, all we need to do is isolate A, and then we get our P and not Q implies R, right? This being our R. A equals B squared over 4C. But what we need to know, and we do know, since BC does not equal to 0, so BC does not equal 0, this implies that B can't be 0 and C can't be 0, right? Because if either one of them were 0, that means if B was 0, then this 0 times anything would be 0. If C were 0, then 0 times B would be 0, right? But since the product here is not 0, that means both B and C can't be 0. So what that helps us with is with this equation here, now we know we can divide both sides by C because we know C is not 0. So this implies that B squared over 4C is equal to A. And that's exactly what we wanted to show. We wanted to show that A was equal to B squared over 4C. So we proved that this was true, right? P and not Q implies R. So that means that our original statement is true. So we've proven what we've set out to do.